It's really as simple as using a horizontal line like you see here. And you're going to want to stick around because in this video, we're also going to show mathematically why a simple horizontal line can tell you if the inverse of a function exists. Let's get started. Hey everyone, Dave here. Here's a simple parabola, y equals x squared. I happen to draw one horizontal line, but you can draw it wherever you want. And you'll find that no matter where you draw it, a horizontal line will always intersect the parabola in exactly two places, except for one corner case, when the horizontal line happens to be the x-axis. Now, why is this important? Why do we even care about the number of intersection points that a horizontal line has on the function f of x? Well, before I get into those details, if you haven't already, hit that subscribe button and turn on that bell notification. Let me know in the comments below what other topics you'd like to see in pre-calc. We really have a simple thing to look at here. If a horizontal line, just one, happens to intersect y equals f of x in two or more places, this proves that the inverse of the function f of x does not exist. Now you got to be careful because when you have a function, sometimes you'll draw a horizontal line and you'll be like, yeah, it doesn't intersect in two or more places. It happens to hit f of x in just one spot. The inverse function exists. Is that always the case? Well, not so fast. We have to be very careful that when we're graphing a function, that you graph enough of it to make sure that you're not leaving out in your graph a part where a horizontal line would happen to hit it in two or more places. The cool thing about this trick, and where you save a lot of time, is you just got to find one and only one horizontal line, where if it hits the graph in two or more places, you've just proven that the inverse function doesn't exist. Why does this work? How can we use a horizontal line and make a proof that an inverse doesn't exist? Well, let's go back to the definition of a regular function versus the inverse. For a regular function, you may already remember that you can use what's called the vertical line test instead of a horizontal line test. In a vertical line test, when I give you a function f of x, you can be assured that it doesn't matter where I draw a vertical line, it'll never hit the function in more than one place. And this goes back to the idea of a domain and range as part of the definition of a function. If you remember, the domain of a function gives you all values of x where you're allowed to plug them into the function, and you're not breaking any rules, such as a result where you're dividing by 0, or if we're just talking about real numbers, a result where you would be taking the square root of a negative, because that wouldn't be allowed. And similarly, the range happens to talk about the output f of x versus the input of x. So with the range, we're looking at all the possible values of y. Okay, well, how does that relate back to an inverse of a function and the horizontal line test? Well, before I jump back to that, let me quickly remind you that with the vertical line test, mathematically, the reason why on a graph, a vertical line not hitting the function in more than one place at a given point tells you that it's one-to-one is because it means that if I were to choose any two separate values of the input x, they both would never give me the same value of y. Because if they did, a vertical line then would actually hit multiple output values of y. So that essentially is telling you we have a one-to-one relationship where if I have one specific value of x, I will always get one and only one value of y at most. Going back to the original problem, this horizontal line test. Well, just like you use a vertical line for a function, when we're talking about the inverse of a function, you can think of a horizontal line as being the inverse of a vertical line. Okay, well that's not really a formal proof, and mathematically that might not be convincing. So let me go ahead and show you in the example of y equals x squared, where if mathematically we try and solve for the inverse of this function, that the result will not be a function because it'll fail the vertical line test. So going to the original problem below and rewriting it, y equals x squared, when you want to find the inverse of a function, what you're going to do is everywhere you see x in the function, you're going to plug in y instead, and wherever you see y, you're going to put in x. So y equals x squared becomes flipped. It is now x equals y squared. And what you want to do next is solve for y, and so when you take the square root of both sides, you're going to get that y equals plus or minus the square root of x. And the plus or minus are very important here because remember when you take the square of a negative, you get a positive result. And for example, I'm showing you 2 points here, 9, -3, along with 9 and 3. In both cases, when you square the value of x, or sorry, I should say when you square the value of y, you'll get x. So for example, -3 squared is 9, and similarly 3 squared is 9. So on the graph to the right, you'll notice that both 9, -3 and 9, 3 are valid points on the graph. And I drew a vertical line at x equals 9 to show you that the vertical line happens to intersect the graph at 2 points, 9, -3 and 9, 3. And I drew a couple other different vertical lines as well, because just like in our original parabola that was upright facing, you'll see that a vertical line happens to always hit the graph at exactly 2 points everywhere, except for in this case, at the origin itself, we would, again, only hit the graph at the vertex. It just happens to be flipped versus in the original problem. So you're seeing here visually that we found the inverse of y equals x squared to be x equals y squared. But guess what? It fails the vertical line test. So what that's telling us here is that x equals y squared is actually just a relation. It's not a function. And what that means then is that because in the original problem, our horizontal line test hits the graph y equals x squared in 2 or more places, this shows why when we did the result mathematically that the inverse happens to not be a function. So in other words, the inverse function of y equals x squared does not exist. So I hope this video was helpful to you. Be sure to check out the other videos you see pop up on your screen. And again, leave a comment if you haven't already, and I'll catch you later.